That means for this a given to integers a and b, there exists only unique pair of q and r and not another pair. That we have to prove. Now this we shall consider. Suppose a has two expressions, or that means a can be written in two ways, as a is equal to qb plus r, and that is also equal to q dash b plus r dash. So here we have expressed a in terms of two ways. qb plus r, here is a pair q and r, and q dash b plus r means in the pair q dash and r dash, where r and r dash has the same condition. For r, 0 less than or equal to r less than b, and 0 less than or equal to r dash less than b. Now from this equation we shall consider r dash minus r. R dash minus r is equal to, take this r on that side and q dash b on this side, and b is common, so b into bracket q minus q dash. If you take the absolute value of this, therefore mod of r dash minus r is equal to mod b into mod q minus q dash. But we know that mod b is same as b because b is greater than 0. So therefore this will be mod b first, q minus mod of q minus q dash, that is mod of r dash minus r is equal to b into mod q minus q dash. So this is the relation we have. Now we consider these two inequalities. From the first inequality we multiply it by minus. Next, if you multiply by minus 1, we know the inequality reverses. So this will be minus b is less than minus r is less than or equal to minus 0 is same as 0, and we take this second inequality as it is, that is 0 less than or equal to r dash less than b. Now we add these inequalities. Adding these, what we will have is minus b plus 0 is minus b. Now the relation will become strictly less than r minus r plus r dash, means r dash minus r less than 0 plus b is b. Now what this implies is the absolute value of r dash minus r is less than b. So this implies mod of r dash minus r is less than, strictly less than b. So what is the meaning of mod x is less than a means this implies minus a is less than x is less than a. If we have this relation, then we can write mod x is less than a. So the same way we have written mod of this value, absolute value is less than a. Now we will consider this relation. You see, mod of r dash minus r is less than b, and but mod of r dash minus r is b into mod of q minus q dash. So we can refer this as next equation, or we directly consider this. Therefore we have, replace r mod of r dash minus r by b into mod of q minus q dash, and that is less than b. Yes. and now we can divide both sides by b. So therefore mod of q minus q dash is less than 1, dividing by b. And also mod value is greater than or equal to 0. Absolute value is always greater than or equal to 0, non-negative. Therefore we have the relation 0 less than or equal to mod of q minus q dash is less than 1. And now what this suggests? Q dash are integers, so their difference is also integer, and this is an integer which is between 0 and 1. So but there is no integer between 0 and 1, and therefore to satisfy this inequality this must itself be 0. So this implies mod of q minus q dash is equal to 0. Then it will be true, otherwise it is not true, because there is no integer between 0 and 1. And therefore this is 0 means q minus q dash is 0, and this means q is equal to q dash. And now see, if q is equal to q dash, from this relation you see q minus q dash is 0, therefore r dash minus r is equal to 0. Therefore we have, now we may refer this as say this equation, this relation as, or this one as 2 by 2. R dash minus r is 0, and this implies r is equal to r dash. Thus q is equal to q dash and r is equal to r dash, means the pair q and r is unique. If you assume different pair q dash r dash, then it is same as the original pair. So this proves the uniqueness of q and r. And thus now the theorem is complete. So we have proved for given integers a and b with b positive, there exist unique integers q and r such that a is equal to qb plus r, where r lies between 0 and b. So this completes the proof. Now what we have considered here in this theorem of division algorithm is b is positive. There is condition on b greater than 0, positive integer, and there are no condition on a and other q and r. There is condition for r. So there is condition for b and r. These are non-negative integers. B is actually positive and r is non-negative. But whether b can be negative, yes, b can be negative, and that is the more general form. It is not necessary that b is always greater than 0. We can consider b negative, and that will be a more general form of division algorithm. So we write it as a corollary. General form of division algorithm. Now, what is the general form? This condition is only b is not equal to 0. One that is necessary. B, actually we are dividing a by b, and we can't divide by 0. So b must not be 0. B may be positive or negative. So the form is given integers a and b with, now this condition we shall change, b not equal to 0. Maybe not equal to 0 means it may be positive or negative. There exist unique integers q and r such that a is equal to qb plus r, and here we will have 0 is less than or equal to r is less than absolute value of b. If b is negative, then we must take its absolute value. So this is the change in the division algorithm and general form of division algorithm. What is the change? B greater than 0 is replaced by b not equal to 0, and here b is replaced by absolute value of b. Now we have proved the theorem for b greater than 0. Now we shall prove the theorem for b less than 0, or we shall consider the case b less than 0. We consider the case of b less than 0. Greater than 0 we have proved. Now we will consider b less than 0. Therefore, if b is less than 0, then mod b will be greater than 0. Absolute value is always positive. If b less than 0, suppose b is minus 3, then what is mod of minus 3? That is 3. And therefore mod b is greater than 0. And now the theorem 1 can be applied for mod. So therefore, applying theorem 1 for a and mod b, for integers a and mod b, there exist. So there exists another integer. That means, so instead of q and r, there exist integers q and r. We will say q dash. There exists q dash and r. So applying theorem 1 for integers a and mod b, there exist another integers q dash and r such that a is equal to q dash mod b plus r, and 0 less than or equal to r is less than mod. Now you note the change for division algorithm and general form of division algorithm. Instead of b, here we have mod b greater than 0. So therefore in this statement we have replaced b by mod b only, and q is changed to q dash. Now b is less than 0. B is less than 0 here we have in this case. So b is less than 0. Therefore what about mod of b? Mod of b will be minus. If b is negative, then mod b is negative of negative, that becomes positive. So therefore we can write this value here, and therefore we have a is equal to q dash mod b is minus b plus r, 0 less than or equal to r is less than mod. And now we shall consider this negative sign with q dash, or that is a is equal to minus q dash into b plus r, 0 less than or equal to r less than mod. Now we take minus q dash is equal to q. This number we shall consider as q, and therefore we have a is equal to qb plus r. 0 is less than or equal to r is less than mod of q, and this proves the result. Hence you see this is the corollary, hence the result. So that means for division algorithm, integers, there should be two integers a and b. What is the condition for b? Earlier case we have considered b positive, but here we have considered b negative also. Only the condition is b must not be equal to 0. The second integer, we are dividing a by b and b must not be 0. We can't divide by 0. And then there exists another pair of integers, unique pair q and r, such that a is equal to qb plus r. So that is the meaning of division algorithm. Division algorithm is the process of division, that usual division, simple division we learned in high school. And the same process is explained in the form of theorem. So, but the theorem is, you may see, lengthy somewhat and difficult to understand immediately. But by practice you may understand the theorem, and you have to understand by repeating it. So we shall consider examples of division algorithm now. Let's see. So if b is positive, the examples are very simple. And if b is negative also, we shall consider illustrations of this division algorithm examples. Let a is equal to any number that is to be divided by b, and you see the smaller or greater, whichever it may be. A may be smaller, b may be greater, or vice versa. There is no condition. So I shall take a as say 13 and take b as, so you may take b as 5. Then a is equal to, a is 13. You see the theorem, a is 13, b is 5. So it is 5 plus r. What are q and r? So this process is simple, that is 13 is divided by 5. The quotient is, we know, 2. And here the product of 5 into 2 multiple 2 is 10. The subtraction is 3. So that's why this is q, this is a, this is b, this is r. And thus we have q is 2. So we write q here, 2, and r last, that is 3. So 13 is equal to 2 into 5 plus 3. So q is equal to 5, therefore q is equal to 2 and r is equal to 3. And you note that this 3 is less than 5. 0 is less than or equal to 3 is less than 5. That means the remainder is always greater than always less than the divisor. So this remainder is either 0 or less than the divisor. Here it is 5. 3 is less than 5. So this is one example of a division algorithm. Now we may consider second as let a is equal to, say a is, we may consider 6, and b we may consider, say, 10. Now 6 is divided by 10. So how do you express it? 6 is divided by 10. The number 6 is smaller, 10 is greater. Whether this division is possible or not, you may say it is not possible, but by algorithm it is possible. Now whenever this number is less than the divisor, we consider the quotient as 0, and the product of 10 and 0 is 0, and the remainder will be 6. So this is r, and condition is this 6 is less than 10, so it is satisfied. The quotient is 0, so then we can write 10 is equal to, yes, q is 0 and b is 6. plus remainder is 6. 0 less than or equal to 6 less than 10. This is the second example of division algorithm like this. So you remember always this is A, this is B, and this is Q, this is R. So that is the second example. Likewise, you can construct another examples. Now we consider the case of B is negative. So let A is equal to 3 and let B is equal to say -5. Then what about this? So we must have A as 3 and this is -5B. Q must be here and plus R must be the remainder. Now what should be the quotient and the remainder here? So the remainder must be less than this divisor. Divisor is here mod B. Mod B is, now we have to use this here. A is equal to QB plus R and R must be less than mod of B. Mod of B is 5. So therefore we may consider this as 1 here. So it is -5. -5 plus, now if you consider -5 plus which number is 3? -5 plus 8 will be 3, but 8 is greater than 5. So therefore 1 we should not consider. And if you consider -1, then it is 5, which will be 5 plus again, that is negative. We can't consider negative. So therefore what we shall do is, we consider this as or 2 we may consider. Then it is -10. So but then also R is the remainder. So -10 we have to consider 30, which is greater than which is greater than 5. So therefore we should not consider this as say, and therefore we will consider it as, if you consider minus, it is 1 itself, -5. -5 plus 8 it will be. Take your numbers one by one. Of 3 is divided by -5. Now if you consider the quotient as 0, because this number is numerically less than this number, so we should, in this case we should consider the quotient as 0. And now what is the remainder? The product here is 0, the difference is 3, so it is alright. Then we have this as 3. So 3 is equal to 0 into -5 plus 3, and then this 3 is 0 less than or equal to 3 is less than mod -5, mod t. This condition is satisfied. So this is the case when A is 3 and B is -5. Now we consider the next case as a fourth example. Let A is equal to 5 and B is -7. Or we may consider A as instead of 5, 15. Now here what we have to consider is 15 is divided by -7. And we want to write 15 is equal to -7 into some number plus. So we may consider here now say -2. Then the product of these two is 14 and the remainder is 1 plus 1. So this remainder is satisfying the condition 0 less than or equal to 1 is less than mod of -7. So in this way we can find, for any pair of given A and B, we can find Q and R. So here Q is -2, R is 1. Here Q is 0, R is 3. Here Q is 0, R is 6, and so on. So you may try for such type of examples. I shall give one for you to work. Let b is equal to, say b is equal to minus 4, or yes, you may take b is minus 4. Find q and r for a is equal to. Now I will take the numbers as a is equal to 2, then 5, then minus 6, minus 10. So take one by one, that is a is equal to 2, b is equal to minus 4, a is equal to 5, b is equal to minus 4, and so on. Find q and r for this and express like this. Express a is equal to qb plus r in this form. Find q and r. So this will be the examples, illustrations for division algorithm. So okay, the examples from exercise we shall consider next time. Thank you.